Hello, everyone. Thank you for this presentation. So I'm Jonathan Chemou, I'm Moshe Malawach on Twitter, Telegram, etc. From NULS, it was 4 days ago, so not really anymore. Today we will talk about decentralized computing and how we managed to create a decentralized computing network and what are the commercial implementation of it today, and what can we do with a really decentralized network. So I'm the CEO and co-founder of aleph.im. I'm based in Paris, France. In the past, I've worked on a lot of stuff like technical management position in the financial sector, IoT, open source stuff for years. So, a few words about us before I start. We have been created in 2019. We have had a Series A stage fund with $11.5 million to date. We have a computing network which is live with more than 70 plus core channel node. I will come back on what it is, and 200 plus computing resource nodes. And we have big names in our ecosystem like Ubisoft, Request Network, Oasis Blockchain, Synapse, Binance Smart Chain, Polygon, Ethereum, Solana, etc. So the idea of our network is that we have multiple kind of nodes. Controller nodes, which are the core channel nodes, and computing resource nodes that are actually doing the work. Like, if you need computing, you need virtual machine supervisors. You need storage nodes that are storing a lot of data. You need to even have a database where everything is signed, taken into account, etc. We support multiple kinds of virtual machine and computing on our network. Micro VM, for those who know, which are what is used for serverless computing. For example, if you know Amazon AWS Lambda, that's what it is. You do a call, it launches your program and gets you a result. It can even run container, and it can be spin up in 500 milliseconds approximately. Then persistent virtual machine, which are EC2 instances on the AWS world, and what we will have soon as well, which is confidential computing based on AMD SEV, where your full virtual machine is totally encrypted, and it's RAM as well, and it's storage as well. So even the node owner can't see what is happening inside. Like a node owner can't stop your VM, look inside it, and restart it. That's pretty important. If you do MPC, you want ideally to have each share inside a confidential VM. So a bit deeper look into our nodes. The core channel nodes are what we call the controllers of the network. They're managing our database. Basically, everything on aleph.im is a message, hence the name aleph.im, which stands for instant messaging. And those nodes manage a database where each message is signed with a private key, and these sent with an address which can be an Ethereum address, Solana address, Polkadot ecosystem address, Cosmos SDK address, or whatever. And nodes will know how to verify that the signatures are good for this address. And we can also have virtual signing, which comes from on-chain, which is another story. And they verify that those that are doing the computing and storage are really doing it. And they are provisioning API endpoints for people who want to interact with the aleph.im network. They verify transaction on-chain. The good part with it is that we don't have a consensus inside aleph.im. What we do is that we are continuously writing on-chain and verifying what is happening on-chain to use the Ethereum consensus for security. And then we have the computing resource node, which are those that are actually the virtual machine supervisors. They manage the virtual machine, they spawn micro VMs, they redirect API and domains to like micro VMs, they manage instances for your workloads, etc. And soon they will also do confidential computing with specific kind of computing resource node which are on the correct architecture. So if you look inside our micro VM system, like you have a cluster of micro VMs that have access to like external resources which are accessible like using the TCP/IP stack. Your micro VM can have a specific IPv6 so that you can directly contact your VM through the internet. Since IPv4 are pretty much scarce, we can attribute an IPv4 to like each VM, but we can attribute one IPv6 per VM. And then you have access to like your decentralized application can like directly talk with like your micro VM. The idea with that is that if you have an existing application that is done using a Linux stack, you can just put it on aleph.im. You don't even need to like change your code for it to work on a decentralized network. So a few case studies on decentralized compute, like there is storage and indexing. Like you could do a decentralized Google Drive or whatever. You can do indexing of protocols, like for example DeFi protocols. And on the gaming side, you can do dynamic NFTs with VRF and Oracle stacks. So our indexing design, basically, when you do the first call to like your indexer using a GraphQL request, it will first launch it on like a new node. It will get the current state and then get back into history to like get the full state of your smart contract program, etc., and then serve it to you in GraphQL, and then it will do snapshots that can be reused by like other instances that are run, so like they can be spawned up instantly and get access to like the current state. At one point in February 2022, before the FTX collapse and everything, 90% of Solana projects were using our indexing solutions. Now on the gaming side, we have another commercial implementation, which is the VRF. The VRF is basically a verifiable random functions. You will like initiate a query to get a random number. It's not necessarily on-chain, and it's not necessarily through an Oracle. It can be directly from an aleph.im off-chain app or from a game, for example. It can request a VRF, then like nodes will like generate their own part of the VRF. And basically, they will write every proof on our network as database entries, and then the coordinator will take all these shares of a random, compute the global random in a verifiable way, and then publish it. And then anyone that can verify this random can. And this random will be stored on the aleph.im network as a database entry. If you need it, you can use oracles to like write it on chain, but it's not mandatory. And there is a good use case for that VRF, which is gaming. Like for gaming, you don't need to like do on-chain transaction for like each random, but if you need to like mint an NFT, you will use that random inside the NFT. If there is a fight, you can ask for a random, get it to like get a fight outcome or something like that. And if it's off-chain, it can be pretty much instant as long as like all the nodes are reacting fast enough. Then we have an Oracle design as well on top of aleph.im. Again, you request a specific write on-chain. Like the Oracle writers are deployed inside confidential VM. If they are set to like use MPC, each one will like compute its part of the key, its own part of the signature, and then send a transaction on chain with your Oracle value, basically. So a commercial implementation of these last products, which is with Ubisoft, and the Quartz product, which is a way to like have real AAA game NFTs on chain. When you have an NFT, you have the metadata URL, which generally points to like either centralized servers or IPFS. If it's on IPFS, it can't be changed at all. While if it's on a decentralized network and it's on a .aleph.cloud something, or like even on your own domain that points to like the aleph.im network, a micro VM can like compute in real time the content of your NFT. And if you have off-chain action like in your game, like let's say you like did a fight and your weapon got damaged, then your NFT metadata can like instantly be changed in a verifiable way, so that your like weapon can be damaged inside your NFT too. It adds a lot of issues there, like what happens if someone is trading the NFT while he's playing and he's trying to like sell something that is damaged, or like someone tries to like do MEV to like buy something that just got upgraded or stuff like that. And that's where Oracle can come into play to like stop trading if it's into an active game or stuff like that. Then we have on Oasis layer 1 and layer 2. For those who aren't familiar, Oasis and layer 1 and Homeverse layer 2 have been chosen by Square Enix, Sega, Ubisoft, and a few others who are now developing new games on top of it. And we're basically just deploying all that for these games and our partner Ubisoft, obviously. Now something a bit more trendy, which is AI. And I think that it's perhaps one of the best use cases of decentralized computing today. Because if you think about AI, we mostly think about big GPU farms. And there is OpenAI that is providing APIs, ChatGPT that like everyone knows, but it's extremely centralized. And if we want to like have a really democratic AI or stuff that are unbiased, or if we really want to like put AI onto every service on Earth, we need a decentralized stack for it. Because if everyone starts using OpenAI APIs for like AI, we are kind of fucked. Sorry. But let's say you have your social security system that is using the OpenAI APIs to like verify that your claim is good. Because why put someone to like verify a claim if you can just put just put on AI? Well, it works. But if you use a centralized API, that's bad. That's where it comes into play. So like basically we have LLMs running on the aleph.im network with VM processing users' conversations. Let's have a look at the past of AI and why it's possible now. In the past, you like had to like use big NVIDIA GPUs, A100 and now H100s, with a lot of VRAM. VRAM is like the name of the game inside large language models. Like you needed to like have 100, 200 gigabytes of VRAM to like like run one model. That doesn't work in a decentralized way. You can't have 5 A100 which cost 30K per card on one server. No. And then Llama got released by Meta, or more like leaked by Meta or someone who leaked it, we don't know. And then the open source community went totally crazy and started developing around it, doing fine tuning, doing LoRa, which is local attention. Like basically it changes, it does a fine tuning on the base model on like each step of the inference. And it allowed to like get way better results. It started with like the with like the Vicuna models, etc. And then came the quantization, because when you run a model, it's basically in 16-bit. But if you look at a picture and it's in 16-bit of colors and you put it into 8-bit of colors, you see a little bit of difference, but it's not huge. Well, it's the same way for like LLMs. And one LLM that ran with like 40 gigabytes of VRAM soon worked with 20. Now it fits into a 4090, 3090 NVIDIA GPU. That's nice. It can start to be decentralized. And then came quantization in 4-bit, 2-bit now, and now what we call mostly 2 bits, like adaptive quantization. On some part it will be 16-bit, on some part 8, on some part 4, 3, 2 bits of quantization. And way less VRAM. Now you can run a large language model on a GPU that has 8 gigabytes of VRAM. And you can even run it on a CPU, and it works. And just 2 days ago, a new model came out with just 1.5 billion parameters based on the textbooks is all you need paper by Microsoft. And it runs on very small feature phones. Like it's totally crazy, and quality is going up, and processing power needed to like run large language model is like clearly going down at a really, really fast pace. And yeah, so like Llama version 2 got released with commercial use open, and you can just deploy it with no legal problem on a decentralized cloud. On the models, if you look at Wizard Coder, which is based on Llama Coder version 2, it surpassed GPT-4. If you look at here, it's Wizard Coder 34B, and here it's ChatGPT for general availability. And on benchmark on Python, it surpassed it. So we are at a point where open source models are getting better than ChatGPT, at least on coding tasks. So how does it work exactly? Like on demand, when there is one request for inference, which is text generation, you find a node for the user, you load a VM with the inference software, it closes the LLM as a volume from IPFS inside the virtual machine, starts context processing the prompt plus the history, it starts streaming the result to like the user, and it keeps the VM alive for the next call. And what we will have in the future to like expand AI capabilities on the aleph.im network, GPU support, fine-tuning on the network itself, like you could just put your own documents and it will fine-tune a model for you on a decentralized network, like spawning as much VM as needed, generate images, doing multimodal inference and context injection. This means that you can not only put text as a context, you can also put pictures, whatever, and generate audio, video, images, etc. So this is live on libertai.io. You can use it yourself on chat.libertai.io. I think that I already talked about the role in impact, and let's go directly to like a little demo. You can connect your wallet. And the Connect Wallet feature is quite interesting. Here, right now, if you use it just to like opt in for like an airdrop, but the idea is that in the future, you can share what you are talking with the bot if you opt in, and then Liberty can like do fine tunes on what you are talking with the chatbot on, and you get rewarded for helping fine-tuning the models. Because if you use ChatGPT right now, you are helping them for free. With Web3 and crypto, you can be rewarded just for like helping do that. So now on the API, Liberty has a very simple REST API, which are going on like created.aleph.cloud/VM/API/v1chat/generate. This is compatible with Cobalt for those who know. So like here is an example of like API call. Basically, I am just prompting it to instruction Python hello world code in a function and accepting command line arguments. This is the curl command to do it. Here is the result, and here is the Python code that generated. And this is the model that surpassed GPT-4. So like, we will also share the slides soon, and you will be able to do it yourself using that API as well. So thank you everyone for like listening to me today. I'm a bit jet lagged, so sorry if I was a bit stuttering or whatever. I'm really tired. Thank you very much.